find out the solution as usual, as we do it in the previous methods, right? So here this can be written as d square plus a square into y is equal to secant ax. Okay. Now what we need to do is find out yc. So to find out yc, we need to find auxiliary equation. So that means m square plus a square equal to 0 implies m square is equal to minus a square, which can also be equal to m is equal to plus or minus ai. Okay, root of a square is 1, sorry, root of a square is a, and under root minus is there, so we'll get complex number. So therefore, yc or y can be written as how much? Complementary solution.
C1 cos AX
C1 cos ax
plus C2 sin AX.
sin ax. Okay, so this one. Now here what we are going to assume is this one is y1 and this one is y2. So y is equal to c1 y1 plus c2 y2. So therefore y1 is equal to cos ax, y2 is equal to sin ax. Okay, now y1 dash we need to find. Y1 dash will be how much? Minus a sin ax. Similarly, y2 dash is equal to a cos ax. Okay. Now after finding this, we will find the Wronskian. W is equal to cross multiply this. Okay. So y1 y2 dash minus y1 dash y2 is equal to y1. y1 is nothing but cos ax into a cos ax. Okay. Similarly, minus sin ax into a sin ax. Sorry, minus a sin ax. Minus sin ax into minus a sin ax. Okay. So therefore, Wronskian W is equal to a cos square ax minus of minus plus a sin square ax. So W is equal to a of cos square ax plus sin square ax. Okay, so W is equal to how much? This value is 1. So A into 1 will get here. So therefore, we'll find first A dash of x. A dash of x can be defined as minus y2 phi of x divided by Wronskian W. Similarly, B dash of x is equal to y1 phi of x divided by Wronskian W. Okay, so A dash of x is equal to minus y2. So minus sin ax into phi of x. What is phi of x? This one.
Secant.
Okay, so this is nothing but secant ax divided by Wronskian. It is a. Similarly, b dash of x. y1 cos ax into secant ax divided by Wronskian is a. So a dash of x, simplify this, minus 1 by a sin ax divided by secant ax can be written as 1 by cos ax. Okay. Similarly, b dash of x is equal to 1 by a cos ax divided by secant can be written as again 1 by cos ax. So these two get cancelled. So a dash of x is equal to minus 1 by a tan ax. Okay. Similarly, b dash of x is equal to 1 by a into 1. So I'll get this much. Now if you want to find a of x and b of x, how will you find? We need to integrate on both sides. Okay. So therefore a of x is equal to how much? Minus 1 by a integral tan ax dx. Similarly, b dash of x, sorry, b of x we need to find. If you are finding b of x, 1 by a integral 1 dx. Okay, so implies what will be a of x now? Minus 1 by a integration of tan ax. Integration of tan ax.
Log sec x by a.
Divided by a. Next, here b of x. So here, if you want, you can put integrating constant. So plus some k1. Similarly, b of x is equal to x by a plus some k2. Okay, this k1 and k2 are integrating constants. So therefore, y is equal to, instead of c1, you will replace with a of x into y1 plus b of x into y2. Okay, so therefore y is equal to a of x. A of x is minus 1 by a log secant ax into y1 cos ax. Okay, plus k1, sorry, cos ax.
Log sec x by a, sir.
Huh? Log?
Minus 1 by a square.
So you'll get a square here. Okay, minus 1 by a square will get. Similarly, plus x by a plus k2 into sin ax. Okay, so therefore y is equal to, you can, if you want to take LCM as a square, how much will get? A square will get here minus cos ax log secant ax plus k1 cos ax plus ax plus k2 into sin ax. So in this way you can write the solution. Okay. So if you want, you can multiply it and you can write. Let's go through it once. If you get any doubts, let me know. Is it fine? Any doubts? So from tomorrow onwards, please go through integration formulas. So from now onwards, we are going to deal with integrations also. Shall we go for next one?
Yes, sir.
Here he will mention it particularly whenever he is giving method of variation of parameters, means they will be giving like this, or sometimes they will be giving MVP method. Okay, MVP method means method of variation of parameters. Okay, so here d square plus 1 into y is equal to secant x tan x. Okay, so as usual, we'll find complementary solution first. M square plus 1 equal to 0 implies m square is equal to minus 1 implies m is equal to plus or minus I. Okay, so what will be the solution? Yc is equal to
C1 cos x.
C1 cos x.
C2 sin x. Okay, so now we'll take y1 is equal to cos x. Similarly, y2 is equal to sin x. Find y1 dash is equal to minus sin x. Similarly, y2 dash is equal to cos x. Okay, so therefore Wronskian W is equal to y1 y2 dash minus y1 dash y2. Okay, so therefore W is equal to y1. Y1 means cos x into cos x minus y1 dash. Y1 dash means minus sin x into sin x. So W is equal to cos square x plus sin square x. So therefore Wronskian value is 1. Okay. So once we find Wronskian, right? A dash of x is equal to minus y2 phi of x divided by w. Similarly, b dash of x is equal to y1 phi of x divided by Wronski. Okay, so now a dash of x is equal to minus y2. Minus y2 is nothing but minus sin x secant x tan x divided by Wronski. It is 1. Similarly, b dash of x is equal to y1 cos x into secant x divided by 1. Okay. Now a dash of x is equal to minus sin x divided by secant x can be written as cos x, 1 by cos x into tan x. B dash of x, this is nothing but cos x, here tan x is there, okay, into 1 by cos x into tan x. So these two get cancelled. Sin by cos it's tan. Tan into tan, it is tan square x. So a dash of x is equal to minus tan square x. Okay. Similarly, b dash of x is equal to tan x. Now integrate on both sides. So I'll get a of x is equal to minus integral tan square x dx. Similarly, b of x is equal to integral tan x dx. Okay. So therefore, a of x is equal to integral, what is minus tan square x? As you know, secant square x minus tan square x is equal to 1. So implies minus tan square x is equal to 1 minus secant square x. I have sent this secant square x to that side. Okay. So based on this identity, I can replace minus tan square x as 1 minus secant square x dx. Similarly, b of x is equal to integration of tan. It is log of secant x. Okay. So here plus k to you, right? A of x is equal to integration of 1 dx is x minus integration of secant square x.
Tan x.
Tan x.
Tan x plus k1 I will write. Where k1 and k2 are integrating constants. Okay. So therefore, a of x we got and b of x we got. The general solution is y is equal to a of x into y1 plus b of x into y2. Okay, so y is equal to a of x. A of x is first one, x minus tan x plus k1 into cos x plus log of secant x into sin x. So therefore y is equal to, you can write k1 cos x Here plus k2 is there, right? This can also be written as log secant x plus k2. Here plus k2 sin x plus x cos x, because multiply this cos x to inside. Okay. Next, tan x into cos x will be how much?
Sin x.
So I'll get sin x. Next plus remaining thing is sin x into log secant x. So sin x log secant x. Fine. Let's go through it once. Yes, is it fine?
Yes, sir.
Here the main part is writing general solution. Okay. So writing this one and Wronskian and A dash and B dash. If you know these three are on say, you can do this problem. This problem is also very easy problem. So here one problem I'll do, one problem will take it as homework. So which one shall I do? Yes. So which one shall I do?
First.
first one you'll get direct integrals. Better first one you do, second one I will do. Yes, second one is a bit complicated is there. I'll try to do second one. So here d square plus 4 into y is equal to tan 2x is there. Okay, so now what I'll do is m square plus 4 is equal to 0, implies m square is equal to minus 4, implies m is equal to plus or minus 2i. Correct. So therefore y will be how much? Complementary solution
C1 cos 2x
cos 2x
plus C2 sin 2x.
Okay, so now I'll take y1 is equal to cos 2x. Similarly, y2 is equal to sin 2x. Okay, y1 dash is equal to minus 2 sin 2x. Similarly, y2 dash is equal to 2 cos 2x. Differentiation I read. Okay, Wronskian w is equal to y1 y2 dash minus y1 dash y2 is equal to y1. y1 is cos 2x into 2 cos 2x, okay, minus sin 2x into minus 2 sin 2x. So Wronskian is equal to 2 cos square x plus 2 cos square 2x plus 2 sin square 2x. So Wronskian will be 2 into cos square 2x plus sin square 2x. Theta is same, so you can make it as 1. So Wronskian will be 2. Okay. So after finding Wronskian, find out a dash of x is equal to minus y2 phi of x divided by Wronskian. Similarly, b dash of x is equal to y1 phi of x divided by Wronskian. Okay. So a dash of x is equal to minus y2. Minus y2 is sin 2x into tan 2x. Phi of x is tan 2x divided by Wronskian is 2. B dash of x is equal to cos 2x into tan 2x divided by 2. Similarly, a dash of x is equal to minus 1 by 2. Okay, sin 2x into tan 2x. How to write this? Sin square 2x divided by cos 2x. Okay, tan x can be written as sin x by cos x. So sin x into sin x will get sin square x divided by cos 2x. B dash of x is equal to 1 by 2 cos 2x into sin 2x divided by cos 2x. Okay, so cos 2x get cancelled. So a dash of x is equal to 1 by 2 into, how to write sine square x? To make integration easy,
1 minus cos.
1 minus cos 2x by 2.
okay, 1 minus cos square x. Okay, so minus of 1 minus cos square x is cos square x or cos square 2x minus 1 divided by cos 2x. Okay, so this much you'll get. Similarly, b dash of x is equal to 1 by 2 sine 2x. So a dash of x is equal to, if you split this denominator, 1 cos 2x get cancelled, cos 2x will be there, minus 1 by cos 2x. It is secant 2x. Similarly, b of x can be written as 1 by 2 integral sine 2x dx. Okay, so now a of x is equal to 1 by 2 integral cos 2x minus secant 2x dx. b of x is equal to how much? 1 by 2 into, this is minus cos 2x divided by 2, right? Integration of sine, it is minus cos. So minus cos 2x by 2 will get. So a of x is equal to 1 by 2 integration of cos. It is sine 2x divided by 2 minus integration of secant x. Integration of secant 2x. This is nothing but log
Log secant x plus tan x.
secant 2x plus tan 2x. Divided by 2. Okay, and b of x can be written as minus cos 2x divided by 4. So a of x is equal to, you can take 1 by 2 common, you'll get 1 by 4 sine 2x, okay, minus log secant 2x plus tan 2x. And b of x is equal to minus cos 2x divided by 4. Okay, so therefore general solution is how much? Y is equal to a of x y1 plus b of x y2. So therefore y is equal to a of x. A of x is 1 by 4 sine 2x minus log secant 2x plus tan 2x into Here we can have to write k1, k2, right? Integrating constants plus k1, k2 plus k1 into y1 is cos 2x plus k2 minus cos 2x divided by 4. Or you can write this as only this one divided by 4 into sin x, sin 2x. So therefore, y is equal to k1 cos 2x plus k2 sin 2x. Okay, next plus 1 by 4 sin 2x minus log secant 2x plus tan 2x. Okay, next plus, sorry, minus cos 2x into sin 2x divided by 4. So this much will be your general solution. Getting? Here plus k1 you write, here plus k2 you write. Integrating constants.